and today we're going to have a look at thermal decomposition of bicarb soda. What's going to happen if I heat this up? Well, if you guess by the name, decomposition means that we're going to break it up. What's it going to break up to? Well, let's have a look. Right, well, bicarb soda is a great little powder. It's used for a lot of things. Deodorizing, it's really good at taking in smell. So what's it made of? Well, it's sodium hydrogen carbonate. So that's Na, sodium, with a hydrogen and carbonate. Now, when we heat this, so that's a solid, we heat this, it's going to turn into sodium carbonate. Still a solid, but what happens to the hydrogen here? Well, actually, when you decompose a carbonate, it turns into what gives off water. So that's going to be a gas, and CO2, carbon dioxide, which is going to be a gas. So have a look at this chemical equation, and maybe you could tell me, is that balanced? To balance this, you have to count up the atoms on each side, and straight away you might be able to notice a problem with this. There are 2 sodiums on this side and just 1 on this side. So what we can do here is we can just double everything on this side. Now we've got the 2 sodiums, we've got 2 carbons now, and hey, there happens to be 1, 2 there, and we've got 2 hydrogen and 6 oxygen. There's the 2 hydrogen, and we've got 1, 2, 3, 4, 5, 6 oxygen there. So now this is balanced. Now, what's going to happen though to so I'm going to pour some in this beaker, and we're going to heat it up. Now, what would you expect to happen? Well, you can think about that. Well, if we start off with some amount, if you want to do the math on this, and what you could have a look at the relative atomic masses of all these atoms, and what sodium's 23. So let's just look at the molecule. Well, it's not a molecule, but let's just look at this here. So this is, you've got sodium, which is 23. You got hydrogen, which is 1. Carbon, which is 12. And oxygen, which is 16 times 3, which is 48. Add those up together, and you get 484. So 84 grams per mole. Now we've got 2 moles of this, so 2 times 84 is 168 grams per 2 mole. And on this side, well, we're going to have 23 times 2, which is 46, plus the carbon, plus the oxygen, which is 106 grams per mole. Right, okay, the hydrogen here, that's 2 plus the 16, that's 18, and grams per mole. And here we've got 12 plus 32, 44 grams per mole. Okay, so you add this up, 106 plus 44 plus 18, okay, gives you 168. So this makes sense because our conservation of mass says that we can't, law says that we can't lose atoms. Atoms just don't disappear. But, well, what would we expect? Maybe you can figure out the percentage. Like if we heat this up, we lose this and this, the water and the carbon dioxide as gases. We should be left with a solid that is 106. So what's that as a percentage? You should be able to figure that out. 106 divided by 168. So 63% of the mass that we started with. Okay, so this represents 63.1% of what we started with. Let's test it out then. Right, we've weighed this at 50 grams of bicarb soda. We're going to put this on the stove and start the good old chest clock timer, and we'll see what happens. Now, you got to ask yourself, if there's going to be a chemical reaction, what's it going to look like? Well, if there is water, vapor, and carbon dioxide being given off, we should see something, shouldn't we? Now, the first thing you might notice is that it's a bit clumpy. I don't know if you can see, there's a bit of steam coming off it there, so that's why it's going clumpy, because we've got the water vapor, it's just coming out. Okay, we'll have a look. That's at 2 minutes. Right, the next thing, we're at 4 minutes now. The next thing you start to notice just gets, oh, here we go. See those little jets? I mean, they're quite subtle, but it takes on the appearance almost of fluid now. This is a solid. The gas coming off it. Very light. You just see how it kind of floats around. It's getting less clumpy. Cool. Alright, 5 minutes. If you give it a good stir, okay, so we've turned this off. We should stop bubbling. Let's see what it weighs. Right, 31.3. The heat's messing around. Oh, geez, melted it. I've got to look after my scales. Right, so 31.3. So what is the expected weight? 63.1% of 50 grams. 31.5. So not bad. Little expected error. So we started off with sodium hydrogen carbonate, and we end up with just sodium carbonate, and pretty close to our 63.1%. All right, try it yourself.